The human papillomavirus, HPV, is the most common sexually transmitted viral pathogen in the world. More than 100 types of HPV have been identified, and in humans, HPV is associated with 100% of all cervical carcinomas. Two HPV types, 16 and 18, have been associated with nearly 70% of all new cases of cervical carcinoma in women. And in the U.S., 10 women die every day from cervical cancer. Two additional HPV types, 6 and 11, are the cause of greater than 90% of all anogenital warts in men and women. HPV is a highly infectious virus with a non-lipid enclosed icosahedral capsid containing one copy of a double-stranded DNA genome. Up to 80% of the U.S. population, which includes 9.2 million adolescents and young adults, are actively infected with HPV. All sexually active women are considered at risk of HPV infection. Nonetheless, infection with HPV manifests clinically as genital warts in both sexes and different degrees of cervical lesions, including cervical dysplasia and invasive cervical cancer in women. HPV is transmitted through skin-to-skin contact during sexual activity and may not be prevented by the use of condoms. Through microabrasions in the epithelial layers of either the external genitalia or cervix, HPV enters and transits to the basal layer of cells, where the infection cycle begins. HPV-infected cells differentiate and proliferate in the squamous epithelial cell layer up to the surface, where lesions continue to shed new HPV viral particles without destroying infected cells. The site of infection can be flat and invisible, as is more common for cervical lesions, or in some cases, physically raised above the normal surface epithelium as a wart on the external genitalia. Infection of basal cells by HPV can elicit multiple outcomes. Shown here, infection with HPV leads to active replication of the circular HPV genome within the nuclei of infected cells. This mode of infection is most commonly the cause of genital warts and abnormal Pap tests of low-grade cervical lesions. A more concerning mode of HPV infection is integration of the HPV genome into the infected cell's chromosomal DNA. This mode of infection is most commonly associated with high-risk oncogenic HPV types and can be latent and subclinical. However, women infected with high-risk oncogenic HPV types can develop high-risk cervical lesions that, when untreated, can progress to fully invasive cancer. While the complete mechanism of cervical carcinogenesis is not fully understood, research suggests that cellular gatekeepers like the p53 protein are overcome by viral proteins, which results in disrupted cell cycle regulation and aberrant cell growth. In clinical studies of HPV carcinogenesis, cervical intraepithelial neoplasia, or CIN, has been reported to occur as early as 1 year and as late as 20 years after the index case of HPV or abnormal Pap test. HPV-related costs in the U.S. are estimated at $3.4 billion annually. Therefore, new prevention strategies for HPV are emerging, and vaccination is a rational and promising new approach. In the last decade, HPV vaccine development has evolved to using non-infectious, self-assembling virus-like particle, or VLP, antigens of the major HPV structural protein, L1, to trigger the production of antibodies capable of neutralizing HPV upon infection with live virus. For a vaccine to be most effective, it must be multivalent. For example, a quadrivalent HPV vaccine would provide coverage against the two most common genital warts and two most common oncogenic HPV types. As each VLP antigen type contained in the quadrivalent vaccine encounters the immune system, these antigens are presented to B cells, which then become equipped to secrete type-specific IgG antibodies and fight future infections against these four specific HPV types. HPV infection can recur with different HPV types, and multivalent coverage in preventive vaccines may provide the best strategy for controlling infection of both the most prevalent genital wart and oncogenic HPV types. Neutralizing antibodies secreted from memory B cells travel to the site of infection and bind to their target HPV type. HPV viral particle and antibody complexes are cleared by the body before reaching the basal cell layer, thereby preventing the infection cycle. Early intervention prior to the onset of sexual activity is paramount to the prevention of HPV infection. Both genital warts and cervical cancer are preventable HPV-related diseases, and a quadrivalent HPV vaccine in clinical development is expected to prevent the occurrence of genital warts and cervical cancer caused by the 4 most prevalent HPV types.